In this video, I'm going to be showing you how to solve polynomial equations using the rational root theorem. The rational zero test basically tells you that there is a way for you to figure out what are all the possible zeros that a polynomial could have. It's not saying that they're all going to be the zeros, but the zeros will have to come from this list. So, for example, in this polynomial 2x to the fourth minus x cubed plus x squared minus 3x minus 6. To find the possible rational zeros of this polynomial, you're going to take the factors of the constant term, which is 6, and you're going to divide that by the factors of the leading coefficient, which is 2. Now, it is going to be the plus or minus. If you notice this, it's got to be the plus or minus of those. So it doesn't necessarily matter if that was a plus 6 or a minus 6, or even if that was a plus 2 or a minus 2. So all the factors of the constant term are going to go on top. So all the factors of 6 would be 1, 2, 3, and 6. Those are all the factors of 6. And then the factors of 2 are going to be 1 and 2. So now we are going to find all the possible answers from all of these factors over these factors. So when we start with 1, we could have all the possible factors of 1 divided by 1, which is 1, plus or minus, and then 1 divided by 2, which is 1/2. Now, if 2 was the factor that we took from the top, then we could have 2 divided by 1, which is plus or minus 2, and we could have 2 divided by 2, which is 1, but we already have the 1, so we don't have to put that. The next one is 3. So we would have plus or minus 3 divided by 1, which is 3, and then plus or minus 3 divided by 2. And then last, we could have plus or minus 6 divided by 1, which is 6, and then plus or minus 6 divided by 2. 6 divided by 2 is 3, and 3 is already listed. So these are all the possible choices that actually can become zeros of this polynomial. And what I mean is, if you were to graph this polynomial and it crosses the x-axis, these are the only possible rational numbers. Rational numbers. Be careful. I didn't say irrational, meaning square roots. I'm saying these are the only possible rational numbers of where it could cross. We're not sure which of these numbers it would cross at. We just know that these are the only possible choices that we could cross at. So, for example, I want you to list all the possible rational zeros of this polynomial. So what we're going to do is we're going to take all the factors of our constant and divide that by all the factors of our leading coefficient. So we're going to have the plus or minus factors of 3, which is 1 and 3, divided by the factors, plus or minus, I guess, of 2, which is 1 and 2. So therefore, our answer is going to be 1 divided by 1, which is 1, 1 divided by 2, which is 1/2, 3 divided by 1, which is 3, and then 3 divided by 2, which is 3/2. So these are all the possible choices that could become a zero if you were to try to solve this. Now, what does that exactly mean for us in how to actually solve this? You have only learned up until now how to solve quadratics, how to solve the cube, the sum and difference of two cubes, and then how to solve quartics that can be factored. Now, based off of synthetic division, what you have learned in the past, we can now actually find all the zeros. And so here's what you do. First, we're going to figure out what are the possible rational zeros. So first thing we do is take the constant divided by the coefficient. Now the leading coefficient is 1, so therefore we really only have to deal with the factors of our constant, which is going to be 1, 2, and 4. Now what we do with that is we are going to actually use synthetic division. So let's build our shelf, and by synthetic division, our coefficients are 1, 1, -4, and -4. And so what we do is we are going to guess at which of these possible numbers will give us a remainder of 0. We do not know what those numbers are, so we're just going to have to kind of guess and check. So I am always going to start with 1 to me because 1 is always the easiest number to put in the shelf. So if I use 1, I'm going to bring down a 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Negative 4 and 2 give me negative 2. 1 times negative 2 is negative 2. That gives me a negative 6. Okay, that did not work because we don't have a remainder of 0. So we get to start over. All right, 1 didn't work. We could try negative 1. So let's try negative 1. So bring down the 1. Negative 1 and 1 is negative 1. 1 and negative 1 is 0 when you add them. Now you multiply, you get 0. Add, you get negative 4. Multiply, you get a positive 4. And you actually have a remainder of 0. That means that x equals negative 1 is a solution, which is great. Now, at this point, we can do one of two things. We can either make this the new synthetic division, or if it is a quadratic, we can factor or use a quadratic formula. So let's figure out what this is. This, we remember, is a constant. This is the coefficient in front of x. This is a coefficient in front of x squared, which means what is left is x squared minus 4. So since it's a quadratic, we can go ahead and actually factor this, setting the remainder of this, not the remainder because that was 0. We can actually set what is left from the synthetic division equal to 0 to find our other two answers. So to solve for this, we could add 4 to both sides. X squared equals 4. So you would need to take the square root of both sides. And so x would equal plus or minus, don't forget, you took the square root, so it should be plus or minus a 2. So we know that x equals negative 1 was a 0 from synthetic division. And now from factoring, we know that x equals 2 and x equals negative 2 was our other two answers. So let's try this one. We have x cubed minus 7x minus 6. First step, find all the possible rational zeros. So it is going to be the factors of the constant divided by factors of the number in front, which is just 1. So all we have to deal with is constant. So we have plus or minus 1, 2, 3, and 6. So we build our shelf. We have 3. There is no x squared, so please make sure you put a placeholder, sorry about that, in the negative 7 and negative 6. So now we've got to figure out which of these possible rational could be 0. First thing I like to do, I always start off with 1. So bring down the 1, 1, add, multiply, that does not give me a 0 for a remainder. So we get to start over. So I am just going to go ahead and try negative 1. Bring down the 1, multiply, add, multiply, and we actually get a remainder of 0. So we know that x equals negative 1, again, is a 0. Now we are left with a quadratic. This is the constant, this is the coefficient in front of x, and x squared. So if I was to rewrite this as a quadratic, this is something that can be factored. And this factors into x minus 3 and x plus 2. Because negative 3 plus 2 is negative 1x, and negative 3 times 2 is negative 6. So whenever we actually solve these, we will get 3 and negative 2. So we know that x equals 3 and x equals negative 2 are our other zeros. And we have found all 3 zeros. Now, there is a way that you can actually do this by a calculator. Now, there is something called a conjugate. By the irrational root theorem, basically, if you have two numbers, being a and b, and if a plus the square root of b is a root, meaning it is a 0 of a polynomial, then its conjugate is also a root, meaning if you have 2 plus the square root of 5 and it is a 0 of some polynomial, therefore 2 minus the square root of 5 is also a 0. They come in pairs, always. It is called the irrational root theorem. So if negative square root of 7 is a 0 of a polynomial, therefore the positive square root of 7 is also a 0. Again, they come in pairs. You cannot have one square root without its conjugate. There is also something called the imaginary root theorem when dealing with conjugates, meaning if I have 2 plus 3i is a 0 of a polynomial, then 2 minus 3i is also a 0 of the polynomial. If 5i is a 0, that means negative 5i is a 0. If negative 4 minus 8i is a 0, that means negative 4 plus 8i is a 0. Don't forget, you only change the sign in front of the imaginary number or the irrational number. Do not change the sign of the real number. So you actually can work backwards. So a minute ago, we took a polynomial and we figured out what the zeros are. Now, if I tell you the zeros, then we actually can figure out what the polynomial was. So in this case, if we know that there is a 0 at 3, that means we know that there was a factor at x minus 3. If there was a 0 at negative 5, then we know that there was a factor at x plus 5. Remember, you take the opposite sign. And if those are factors, you can then FOIL to get the polynomial function. And that would be your answer. You can do the same thing with a third degree. Now, here's the deal. We know that 1 is a 0 and the square root of 3 is a 0. But remember, we just discussed the irrational root theorem that if you have a square root, then its conjugate is also a 0. That means if 1 is a 0, x minus 1 was a factor. If the square root of 3 was a 0, then minus square root of 3 is a factor. And if negative square root of 3 is a 0, then x plus the square root of 3 is a factor. And now when you FOIL this, here is my hint. Always FOIL the square roots first because it actually comes out very nice. So I'm just going to bring down the x minus 1. When you FOIL this, x times x is x squared. X times the square root of 3 is just x square root of 3. And then you have a negative square root of 3 times x. And then negative square root of 3 times the square root of 3 is negative square root of 9. Here's where it gets really nice. These two terms always cancel. So you're left with x minus 1 and then x squared minus 3. The square root of 9 is 3. And now you can FOIL one more time. So you'll get x cubed minus 3x minus x squared plus 3. Write it in standard form. So it'll be minus x squared minus 3x plus 3 for your final answer. So let's recap. I would like for you to pause the video, work through these two problems, and then resume when you are ready to find the answers to these two questions. All right, first, what we're going to do is we need to find all of the possible roots first. There is no leading coefficient, and so we are only dealing with the factors of 35. So it would be plus or minus 1, plus or minus 5, plus or minus 7, and then plus or minus 35. Now we build our shelf. 1, negative 5, 7, and negative 35. Now we got to figure out which of these terms will get us to our answer. We can try 1, but for some reason I don't think 1 will work because 35 is a pretty big number, and I don't think we can get these numbers to become 35. So I'm actually going to try a 5. So bring down the 1, multiply, add, multiply, add, multiply, and actually we get a remainder of 0, which is wonderful. So since we know it's a remainder of 0, that means I know that x equals 5 is a 0. And we now have a quadratic as our answer because this represents x squared and then this represents the constant. There was no x. So we can now solve this by subtracting 7 on both sides and then getting rid of the square by taking the square root of both sides, and we'll get x equals plus or minus I square root of 7 because there was a negative. So we know that x equals I square root of 7 is a 0, and think about the conjugate theorem that we just discussed. Negative I square root of 7 also is a 0. Write a third-degree polynomial with the given roots. Well, we know 2 and negative 4i, but you got to think about the fact that the conjugate, since negative 4i is a 0, that means a positive 4i is a 0. So if 2 is a 0, then x minus 2 is a factor. And that would be x plus 4i and x minus 4i. Just like with the square roots, go ahead and FOIL these first because something nice happens. So when you do this, you will get x squared minus 4ix plus 4ix, and then minus 16i squared. Don't forget the square, that's a big deal. The two middle terms cancel each other. If they don't, then something went wrong. They should always cancel. That's why the conjugates always work in pairs. Now, I squared, you have learned, is negative 1, right? Therefore, that negative 1 times that negative 16 should become a positive 16. And now you can FOIL one last time. You'll get x cubed plus 16x minus 2x squared minus 32. So to put it in standard form, it would be x cubed minus 2x squared plus 16x minus 32.